If your files are the product of pooling multiple samples onto a single lane, then they are multiplexed and must be demultiplexed before they can be aligned. MODA can accommodate this simply by being informed that the files are multiplexed, and this tutorial will go over about how to do this. As usual, click New Project to create a new project. Here we'll add a project name like Multiplex Test. And before creating the project, let's note that if you know the project organism and strandedness, you can save some time by disabling auto detect mode. Once disabled, it prompts you to select if your samples are stranded or not, and which organism represents your samples. Once done, you can create the project as usual. Proceed to step 2 and begin to upload your files as usual. You can either use the Dropbox by going to the account settings and enabling Dropbox, or use the file browser. Inside the file browser, I'm going to select my multiplexed samples. Here we have 3 different files to represent one single-ended set of multiplex samples. First, I have the reads fastq file, like we did in the de-multiplexed example. A file containing the index or barcodes associated to each read in the fastq file, and a map that correlates the barcodes and samples, as well as any conditions, which we will discuss further with the DEG algorithm. So let's import all 3 of these. Once all the files have finished uploading, you'll notice the file information table is populated as usual. Moreover, in the multiplex column, each of these files is labeled as multiplexed. The group index refers to the fact that each of these files correspond to each other. If you named your files appropriately and their sizes match so that the barcode file is at 80% of the reads file, then everything will be inferred correctly. In this example, we need to use the edit icon to the right to change this file to, say, index fastq file. Save it by clicking the checkbox on the right. Before moving forward, let's review what each of these files are and how they correspond to each other. Here I have 3 different files opened in a text editor. The first reads fastq file, which has the R1 suffix, simply contains all the reads associated for your pool of samples. This is the same type of file that is in de-multiplexed experiments. Here we have the different aspects of a read, where each 4-line increment contains all the information, including the sequence and the quality for that read. Then, for each read in this file, there's a corresponding barcode in the file suffixed by R2. The barcode file looks very similar to the reads fastq file, except for the sequence is usually between 8 and 12 characters. This is simply the identifier that is attached to each of the reads of the R1 file. However, this identifier is not very human readable, which is why we have the sample map. This particular sample map corresponds those 8-character barcodes to actual sample names, and it's delimited by tabs. Notice in the header, it says barcodes with a capital B. Conditions allows you to define which conditions are for each sample, and samples. The capitalization is not important, so each of these headers could be lowercase. Moreover, instead of barcode, if your nomenclature is index, that'll also work. Finally, the pluralization does not need to be there as well. This file can be a .text file, a .csv file, or a .tsv file, as long as it contains at least index and sample, and optionally the condition for each sample. Now that you know a bit more about the files, let's continue. In step 3, we will select the pipeline, and we would choose the algorithms we're interested in running. For the pipeline, we're going to leave everything as is, and for the algorithms, we will select everything. Notice as I select DEG, the list of conditions populates, and it asks us to select a wild type condition. In this example, the condition 2 is the wild type, but each of these names comes directly from the index sample map. So change your conditions to match your experiment as needed. Click Save and Run Project to begin. In the job activity table, we will start to see the progress of the job. Clicking the refresh button will cause it to populate quicker. And notice that the first step is to demultiplex the samples. Once this is done, the remaining jobs will behave similarly to the demultiplexed fastq files. So demultiplexing a multiplexed fastq file can usually be a long process. But with MODA, you can process these files in just a few clicks.